Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 motion in a plane. Today we are going to study about relative velocity. Dear students, till now we completed scalars and vectors in detail. We studied what are scalar and vector quantity, and then we studied about the types of vector quantity, addition of vectors and laws of addition of vectors also we studied, subtraction of vectors, and also we studied multiplication of vectors. In the multiplication of vectors again there are two types and they are scalar product and vector product, or we can also call it as dot product and cross product. Then after that we studied a resolution of vectors. So scalars and vectors is completed. So this is the next part, that is relative velocity. About relative velocity we are going to study in today's session. Yes, we can study about relative velocity. First we have to know what is relative motion. Before going to study about velocity, first we can know about relative motion. You already studied about what is rest, what is motion, right? And also you studied about relative velocity for one dimensional in a chapter motion in a straight line. But we are going to study about relative velocity for two dimensional, that is motion in a plane. So first we have to know what is relative motion. Yes, you can observe here relative motion is the motion of a body with regard to another body is called relative motion. For example, if a person is sitting, he is at rest. Let us consider a person here. This person A is at rest. Here you can imagine the train is moving in this direction. Let us consider this is B. Person A is at rest and the train B is moving. So relative motion means the motion of one body is comparing with respect to another body. Train is moving, yes, it is moving with respect to person we are going to observe. The person is at rest but the train is moving. This is relative motion, the motion of a body with regard to another body. For example, if this person is in the train, he is also inside the train. So here for this person, how it appears? The train and the person is at rest, because for the person he is already inside the train. He is going with the train. For this person it seems to be at rest. Right? When the same person is outside, when he is at the rest, when he is sitting on a bench, when he is observing the train, for him it is moving. This is relative motion. The motion of a body with regard to another body is called relative motion. Then the corresponding velocity is called relative velocity. Right? The corresponding velocity means here the motion of a body with respect to time, that gives velocity. The corresponding velocity is called relative velocity. Here one example is given. When two objects A and B, these two objects are moving along a straight line. Right? Both the objects are moving along a straight line. Let position of the particle A and position of the particle B are XA and XB. Vector XA, vector XB. What it indicates? XA and XB indicates positions of the particle A and B at time t from the origin O. Means we can consider two objects are moving along x-axis and their positions are XA and XB at any time t from the origin O. So I am going to show you the diagram here. This is the origin O. From the origin, two objects are moving in a straight line. The first object is A, the second object is B, right? So here, okay, observe now, XA gives position of the first object, XB gives position of the second object. Then what is the relative motion between A and B? That is XBA. XBA means what here? You can observe XBA equal to XB minus XA. This is relative motion between object B and object A. Right? How to write relative motion here? XBA equal to XB minus XA. Observe here the position of object A relative to that of B. How to write here? If you are going to take object A relative to object B, then how to write the equation? XAB. Vector XAB equal to vector XA minus vector XB. Or if you are going to write the position of object B relative to that of A in reverse order, how to write the equation? Vector XBA equal to vector XB minus vector XA. So here, if you are going to take velocity of an object B relative to the velocity of an object A. Now tell me how you are going to write the velocity object B relative to object A? Yes. Velocity means it is denoted by V. Vector V, BA. Why we have to write BA? Because you can observe the sentence. Object B relative to object A. So we have to write VBA. Suppose if the sentence is object A relative to object B, then we have to write VAB. Right? So now it is VBA equal to vector VB minus vector VA. Is it clear? Yes. How to write relative velocity? If you are going to compare B with A, then we have to write VBA. If you are going to compare A with B, then we have to write VAB. Right? Yes. How to write relative velocity? VBA equal to vector VB minus vector VA. Then how to write vector VAB? That is vector VA minus vector VB. That gives relative velocity. Yes. Yes. How to define relative velocity? The velocity of a body with respect to another body is called relative velocity. Yes. Once again you can watch the definition. The velocity of a body with respect to another moving body is called relative velocity. Now let us derive an expression for magnitude and direction of relative velocity. Yes, observe this diagram. We are going to consider two bodies A and B. These two bodies are moving with velocities vector VA and vector VB respectively. What are vector VA and VB? These are velocities of the body A and B. Angle between these two vectors is theta. It is inclined at an angle theta. Then the relative velocity of A with respect to B is vector VAB. How to write relative velocity of A with B? That is VAB. Now to find VAB, let us draw OS equal to minus VB. The sum of VA and minus VB is given by parallelogram law of vectors addition. Observe here, we considered two bodies. Again here I am going to consider. This is the first body, that is A. It is moving along the line P. So this body A is having velocity VA. It is given here. Then another body is B. It is moving along Q. And this body B is having velocity VB. VA and VB are velocities of the body A and B and inclined at an angle theta. Is it clear? Now we are going to find relative velocity of A with respect to B. That is VAB we have to find here. So we already studied subtraction of vectors because here VAB is equal to, how to write VAB? Velocity of A object minus velocity of B object. That gives relative velocity. So here you can observe this equation VA minus VB. VA is along the line P here. This is for the object A. Now come to the second term is minus VB. VA minus VB, that gives a subtraction of two vectors. We already studied subtraction of two vectors. Remember, In a subtraction of two vectors, we are going to sum the two vectors. Again, we have to add the vectors in subtraction. But this is minus VB. Minus VB means here this is plus VB. Minus VB we can take in the opposite direction. So this will be minus VB. Plus VA minus VB. You already studied subtraction of vectors. When you are going to do subtraction of two vectors, always we have to take vectors in the opposite direction. So this is plus VB, but we want minus VB. So I am going to draw another line opposite to plus VB. So this line I am going to take it as yes. This is having velocity minus VB. Right? Now we have to find relative velocity of A with respect to B. We want VA minus VB. Now we can consider only the line P and S. This is the origin O. OP and OS vectors we have to consider. Now these are just like the adjacent sides of a parallelogram, OP and OS. OP and OS are just like adjacent sides of a parallelogram. So they are going to use parallelogram law of vector addition. According to parallelogram law of vector addition, we know that when two vectors are represented both in magnitude and direction as the adjacent sides of a parallelogram, then the resultant vector is represented along the diagonal of the parallelogram. Now we can take resultant value. Resultant means what here? VAB. VAB is resultant. VA and VB are the two vectors, but this is minus VB, so we took in the opposite direction. Now resultant vector I am going to draw along the diagonal. You can observe here. So I am going to draw the diagonal. So this diagonal gives the resultant vector. Resultant vector here it is denoted by VAB. Vector VAB is the resultant. Is it clear? Now let us join the remaining parts here. So let us take the resultant as R. I am going to join here. This will give a parallelogram. Observe this diagram. Now VAB is the resultant vector. It is along the diagonal. VA and VB are the adjacent sides of a parallelogram. Right, now I am going to consider angle alpha. Angle alpha is angle between vector VA with respect to resultant vector. Right, so let us take it as alpha. Then what is the angle between vector VA and vector VB? Vector VA and VB is theta. But here we considered VA and minus VB. So now tell me what is the angle between vector VA and VB. This angle we want. Now tell me what is the angle between VA and minus VB. We know that total angle is how much? 180. Half of the angle is theta. So remaining will be how much? 180 minus theta is angle between vector VA and minus of vector VB. So this diagram only here you can observe VA and minus VB. These are the two vectors. Resultant vector is along the diagonal, that is VAB. Angle between VA and minus VB is 180 minus theta. Now I am going to derive magnitude and direction of relative velocity. We already derived magnitude and directions using parallelogram law of vector addition. You can observe here. I am going to consider magnitude of two vectors. We already derived. You can observe this expression r equal to square root of p square plus q square plus 2pq cos theta. So this equation we already derived using parallelogram law of vector addition. So this gives magnitude. Similarly, we derived direction of two vectors. You can remember tan theta equal to q sin theta divided by p plus q cos theta. This expression also we already derived. So that gives direction. Now I am going to use these two equations to find magnitude and direction of relative velocity. Yes, now let us find magnitude of relative velocity. Yes, I am going to consider magnitude here. Magnitude of relative velocity means VAB. Magnitude of vector VAB we have to find here. Yes, now I am going to write using this expression r equal to square root of p square plus q square plus 2pq cos theta. This equation we can use here. So I am going to write vector VAB, this is the resultant vector r, is equal to square root of, in place of p square I am going to write VA square. Don't write arrow mark because we want only magnitude here. We are going to find magnitude, so don't write arrow mark. VA square plus, in place of q square we can write VB square plus 2PQ. PQ means VA, VB cos of theta. Theta is angle between VA and minus VB. So we can take 180 minus theta cos of 180 minus theta. Yes. Now let us solve magnitude. Square root of VA square plus VB square plus 2VA VB. What is cos of 180 minus theta? See here, cos of 180 minus theta is equal to minus cos theta. Got it? Similarly, sine of 180 minus theta equal to plus sine theta. These two values you have to remember. Now here this is cos of 180 minus theta. So I can write minus cos theta. Right, or we can write it as a square root of VA square plus VB square plus into minus will be minus 2VA VB cos theta. So this is an expression for magnitude of relative velocity. What is the expression here? Vector VAB is equal to square root of VA square plus VB square minus 2VA VB cos theta. This gives magnitude of relative velocity vector VAB. Now I am going to find direction. Yes, now let us find direction here. Direction of relative velocity, that is VAB. Let us find direction. Now I am going to use this above equation, tan theta equal to q sin theta divided by p plus q cos theta. Same equation I am going to use here. Tan theta equal to q sin theta. In place of q we have to write VB sin. In place of theta we have to write 180 minus theta divided by p plus q, VA plus VB cos theta. Theta is what here? 180 minus theta, because angle between vector VA and minus vector VB we have to consider. Then tan theta is equal to VB sin of 180 minus theta is what? Plus sin theta. So directly I can write sin theta divided by VA plus VB cos of 180 minus theta is minus cos theta. So we can write here minus VB cos theta. So this is an expression for direction, or if you want you can write instead of theta. Theta is what here? This gives direction. So I am going to write instead of theta we can write alpha, because alpha is angle between vector and resultant vector, that is VA and VAB. Therefore, alpha equal to, when tan is taken to RHS side, it will become inverse. So, alpha equal to tan inverse of VB sin theta divided by VA minus VB cos theta. So, this is an expression for direction of relative velocity. So, this is magnitude and direction of relative velocity. Right? What is the magnitude? Vector VAB equal to square root of VA square plus VB square minus 2VA VB cos theta. And direction is alpha equal to tan inverse of VB sin theta divided by VA minus VB cos theta. So this is all about magnitude and direction of relative velocity. Now we can study some important cases related to magnitude and direction of relative velocity. Observe the first case. If two bodies move in the same direction, if two bodies are moving in the same direction, then theta equal to 0 degree because both are parallel to each other. So theta is 0 degree, then equation 1 becomes. Equation 1 means this one, magnitude value. Right? Now observe here, according to first case, if theta equal to 0 degree, so what equation? If theta equal to 0 degree, then equation 1 will become. Observe here, I am going to solve the first case. Theta equal to 0 degree. The equation 1 is vector VAB equal to square root of VA square plus VB square minus 2 VA VB cos theta. This is our equation 1. Substitute theta equal to 0. We will get VA square plus VB square minus 2 VA VB cos 0. Yes, cos 0 is how much? Cos 0 is equal to 1. So the equation becomes VA square plus VB square minus 2 VA VB because cos 0 is 1. Now you can observe this equation. It is of the form A minus B whole square. A square plus B square minus 2AB. So instead of this equation I can write a minus b whole square means VA minus VB whole square. Square root of VA minus VB whole square means, so square root will get cancelled. We will get VA minus VB. VAB is equal to VA minus VB when theta equal to 0 degree. Here it is given VAB equal to VA minus VB when both the bodies are moving in the same direction. So what it indicates? The relative speed between two bodies moving in the same direction is equal to the difference between individual speeds of the two bodies. It is the difference between individual speed of the two bodies. Right? Then come to the second case. If two bodies moving in the opposite direction, then theta equal to 180 degree, then equation 1 becomes. Yes. You can observe here, that is second case. If theta equal to 180 degree, if both the bodies are moving in the opposite direction, theta equal to 180 degree, substitute here in the equation 1. VAB equal to VA square plus VB square minus 2 VA VB cos of, in place of theta I can write 180. Right. Now substitute the value. VA square plus VB square minus 2 VA VB cos 180. Cos 180 is equal to minus 1. You already studied in mathematics. You can remember cos 180 is minus 1. So the equation becomes VA square plus VB square. Minus into minus will be plus 2 VA VB. Now this is of the form a plus b whole square, a square plus b square plus 2ab. So we can write a plus b whole square, that is VA plus VB whole square, or we can write simply VA plus VB square and square root will get cancelled. So this is for the second case. When theta equal to 180 degree, we got VA plus VB. Observe here the second case. VAB equal to VA plus VB when theta equal to 180 degree, and this indicates that the relative speed between two bodies moving in the opposite direction is equal to sum of individual speeds of the two bodies. Theta equal to 0 degree means we have to take difference between individual speed. When theta equal to 180 degree, we have to take sum of individual speed. Right? Then come to the third case. If two bodies moving at right angles to each other, theta equal to 90 degree, then equation 1 becomes. Yes, equation 1 means third case. Here theta equal to 90 degree. Substitute the value. VAB equal to square root of VA square plus VB square minus 2 VA VB cos 90. Yes, now tell me what is the value of cos 90. Cos 90 is 0. Remaining is what? VA square plus VB square. Because 0 into anything will be 0. Square root of VA square plus VB square. So VAB equal to square root of VA square plus VB square. So this is for theta equal to 90 degree. Observe here the third condition. VAB equal to square root of VA square plus VB square. What it indicates? The relative speed between two bodies moving perpendicular to each other is equal to square root of sum of squares of individual speeds of the two bodies. Is it clear? So these are the three cases related to magnitude and direction of relative velocity. So this is all about relative velocity. Again we can study some applications of relative velocity in the next session.